Welcome to the introductory section of the Data Modeling and Design course for business analysts. In this course, we'll dive into the fascinating world of data modeling and explore its crucial role in driving effective decision-making and solving complex business problems. As a business analyst, you're at the forefront of understanding business requirements and translating them into meaningful insights. Data modeling provides you with the tools and techniques to structure and organize data in a way that aligns with business needs, allowing you to analyze, interpret, and communicate information effectively. Throughout this course, we'll cover the fundamentals of data modeling, starting with an exploration of the various data models and their relevance to different business scenarios. We'll delve into entity relationship diagrams. These are a powerful visual representation technique that helps capture entities, relationships, and attributes within a system. You learn how to identify and define entities, establish relationships between them, and attribute characteristics that accurately describe the data. We'll also examine normalization techniques to ensure data integrity and eliminate redundancies in the databases. So by the end of this course, you will have a solid understanding of data modeling principles, techniques, and best practices. You'll be equipped with the skills to collaborate with stakeholders, gather requirements, and create robust data models that support accurate analysis, inform decision-making, and improve business outcomes. So get ready to embark on this exciting journey into the realm of data modeling and design. Together, we'll unlock the power of data and unleash your potential as a business analyst to drive meaningful insights and propel your organization forward. My name is Carlos Ankra, a trainer and agile consultant at Lean Icon Technology and Training. Let's dive in now. We'll start with the database concepts. Talking about data and information, these are fundamental concepts in the realm of databases. Data refers to raw, unprocessed facts, figures, and symbols that represent various elements of the real world. It can be in the form of text, numbers, images, audio, and any other type of digital representation. Data is typically stored in databases and serves as the building blocks for generating information. However, on its own, data lacks that context and meaning. It's often characterized by its attributes, such as its type, the format, and the values. So for example, consider a database containing employee records. The data within this database may include attributes like the employee names, the employee ID or the staff ID, the address, the salaries, the hire date, that's the date that the employee was hired. These individual pieces of data provide discrete information, but they do not offer a comprehensive understanding of the relationships or insights within the data set. Information, on the other hand, is derived from data through a process of organizing, structuring, and interpreting it in a meaningful context. Information adds value by providing insights, knowledge, or understanding that can be used to make informed decisions or gain a deeper understanding of a specific subject. So in the context of databases, information is the result of processing and analyzing data to generate meaningful outputs. This can involve performing calculations, aggregating data, applying business rules, or generating reports and visualizations, just as we can see in the diagram here. Information provides the context and relevance that empowers users to derive insights and draw conclusions. So in relation to the example that we made on the employee database example, information could be generated by querying the database to extract specific insights. So for instance, retrieving a report on employee salaries by department, identifying the highest paid employees, or calculating the average tenure of employees in different roles. These outputs provide valuable information that aids decision-making and supports business analysis. What is a database? First of all, we say that a database is a collection of data, that is organized and related. A collection of data that is organized and related. But this relation should be logical. It should be logically related. So with data modeling, it is all about determining what data we want to capture for a specific purpose, and to then logically organize that data. We also want the logical data sets to relate to each other in some way, because the data work together to produce meaningful information. By organizing data and establishing logical relationships, a database provides a structured and interconnected environment for storing and managing data. It also enables efficient data retrieval, manipulation, and analysis. This organization and logical structuring, they are essential for maintaining data consistency, integrity, and accuracy within the database. A lot of people use the term database system, database management system, and they get confused on when to use or which term is appropriate for which purpose. So look at that. We'll start with the database system. That is a system that refers to a collection of software, hardware, and data that work together to manage and store a structured collection of data. It encompasses the entire environment in which data is stored, data that is accessed and manipulated. So a database system includes the data itself, or the database itself, the software that is used to interact with the database, the hardware infrastructure that hosts the database, that's the hardware that the data sits, and the users who interact with the data in a broader sense. A database system can encompass not only the database management system, but it also has additional components and applications that interact with the database, such as the user interfaces, the reporting tools, backup and recovery systems, and security mechanisms. So as part of the database system, we have the DBMS, that's the database management system. This is a specific type of software that enables the creation, the management, and manipulation of databases. It is a software application or a set of applications that provides an interface. That provides an interface for users and other software to interact with the database. The DBMS handles the storage, organization, retrieval, and manipulation of data within the database. The database management system, also the DBMS, offers a range of functionalities and services, including data definition, data manipulation, data retrieval, and data administration. In data definition, we talk about creating and managing the data structures. For data manipulation, we talk about the inserting, updating, and deleting data. Then there's data retrieval, where we deal with querying the data or retrieving data from the database. Then the data administration is about managing user permissions, security, and performing backups. These are examples of DBMS. We have Microsoft SQL Server, Oracle, MySQL, SQLite, PostgreSQL, Microsoft Access. So someone would be wondering, where does Excel or Microsoft Excel fall into all of this? Some people are of the view that Excel is a database software. Excel is not a database software. Excel is actually a spreadsheet software. So what's the difference between the two? So actually, the spreadsheet and the data both are used to store and manage sets of data. That is, they structure the data sets in rows and columns. They offer a range of processing functions. Both can manipulate data, they can sort and filter data, they can perform calculations on data as well. So both the spreadsheets and databases, they are both used for organizing and managing data. They both have their strengths. With spreadsheets, we could talk about formatting. It's flexible and it's more user-friendly as compared to database that is very scalable and provides opportunities for large storage and security, and then data integrity as well. But they have some distinct characteristics and serve different purposes. So the spreadsheet is simple to understand, whilst the database requires technical knowledge to be able to understand and operate it. On a spreadsheet, the same interface is used for data entry and editing, whereas in a database, there are different interfaces for data entry and editing. Then for the database, there's a centralized data storage and user access security. But in the spreadsheet, user access control is quite difficult to manage. In the spreadsheet, there's duplication of data in multiple worksheets, but the database avoids data duplication and redundancy. How? But it enforces more rules with respect to keys and referential integrity, but spreadsheet enforces less rules with respect to data integrity. So some of the differences is about data structure, the scalability and complexity. We could talk about we mentioned the data integrity and consistency, data manipulation and analysis. We could also talk about collaboration and concurrent access. So in one whole, we could say that spreadsheets are best suited for small and medium-sized data sets, individual projects, and quick data analysis, while the databases do well at managing large volumes of data. It enforces data integrity, it facilitates complex queries, and supports collaborative and concurrent access by multiple users. Now you are torn in between these two. Which one do you go for? Maybe you want to work on a set of data. Should you use a spreadsheet or a database? You need to ask the right questions to get the right answer, or to use the right mode to store your data. One question, do several people need access to the data? And do they need this access at the same time? Do you need to safeguard against erroneous entries when making inputs? Do you need to protect the data that goes into the database or gets stored? Do you have separate data sets that contain related information? Do you want to maintain data for ongoing use, for continuous use? And do you want to combine data and generate specific reports? If you answer yes to these questions, then it's prudent to use databases instead of spreadsheets to store your data. One may be asking, so why does business professionals or business analysts, what's the point in studying a database or understanding data modeling and design? Business analysts play a critical role in bridging the gap between business objectives and technical solutions. Understanding data modeling and database design is very essential for business analysts for several reasons. So look at the various reasons. The first one is on requirement analysis. DAs need to gather and analyze business requirements to identify the data needs of an organization. They must understand how data is structured, organized, and related to effectively capture and document these requirements. The knowledge of data modeling and database design enables business analysts to ask the right questions and ensure that data requirements align with business objectives. The second point, we talk about data integrity and quality. So in data modeling and database design, help ensure data integrity and quality within an organization. The BA needs to understand the principles of data modeling to identify and define entities, relationships, and attributes accurately. They can collaborate with stakeholders and SMEs to establish data standards, validation rules, and quality metrics that align with business needs. The third point is on data analysis and reporting. So BAs often need to analyze data to derive insights, identify trends, and support decision-making. Understanding data modeling enables business analysts to comprehend the structure and relationships within the data, making it easier to query and extract relevant information. They can design effective queries and leverage database design principles to optimize data retrieval and reporting processes. The fourth point is on system integration. BAs would usually work closely with development teams to ensure that business requirements are implemented accurately. Knowledge of data modeling and database design allows the business analyst to effectively communicate the data requirements to developers, ensuring that data structures align with the intended business logic. So this understanding facilitates smoother system integration and reduces the chances of misinterpretation or data-related issues during development. Then the last one is on effective communication. The business analysts act as intermediaries between the business stakeholders and the technical teams. Understanding data modeling and database design allows them to communicate effectively with both business and technical teams. And that bridges the gap between the business requirements and the technical implementation. So this facilitates smoother collaboration, it reduces misunderstandings, and ensures that the data-related aspects are accurately translated into technical solutions. Understanding data model and database design equips business analysts with the knowledge and skills to capture accurate requirements, ensure data integrity and quality, analyze data effectively, facilitate system integration, address data governance and compliance, communicate efficiently with stakeholders. These capabilities empower business analysts to make informed decisions and contribute effectively to the success of data-driven projects and initiatives. So this brings an end to the first session or the introductory section. In our next session, we'll be talking about data models. So let's move on straight to the next section. Thank you.